Right now, as you lie in the dark, you're already sailing through space, spinning with Earth, drifting around the sun. Welcome to Misty Pulsex. If you enjoy peaceful cosmic journeys, tap subscribe and like. Tonight, we'll leave your room far behind and glide from the sun toward Mars on the calmest voyage your mind has ever taken. Settle in, your escape begins now. Right now, while you lie still in your bed, you are flying through space at tens of thousands of miles per hour. Your planet is circling the sun is circling the center of the galaxy. And together, you and everything you know are riding inside a system of worlds held gently by the gravity of a single star. Tonight, we're going to visit that star and then drift outward from it, one planet at a time, on a calm journey from the sun to Mars. This won't be a rushed lesson or a loud science show. It will be a slow, detailed look at the inner solar system, rich with real facts, but told softly enough that you can fall asleep whenever you're ready. You don't have to stay awake for this. You don't have to remember numbers or names. You can simply let the words pass through your mind like light through a window, catching whatever interests you and letting the rest slide away as sleep arrives. If you like, you can let your eyes close now or whenever it feels comfortable. Notice the weight of your body resting on the mattress, the way your pillow supports your head, the quiet sounds in the room or the silence between them. You are safe where you are. Nothing in this story will ask you to do anything. The solar system will keep moving whether you follow every detail or not. The sun is a star that turns matter into light. The center of your system is not a planet, but a sphere of hot gas, mostly hydrogen and helium, so massive that its own gravity squeezes its core to incredible pressures. Deep inside that core, atoms are pushed close enough together that they fuse, turning hydrogen into helium and releasing energy in the process. Every second, the sun converts millions of tons of its own mass into light and heat. That energy fights against the inward pull of gravity, keeping the star stable, balanced between collapse and explosion. You don't need to picture the equations or the exact numbers. It's enough to know that the daylight on your face, the warmth stored in forests and oceans, the electricity in your nerves all trace back to this quiet, ongoing reaction inside a star that has been burning steadily for billions of years. The sunlight that reaches you tonight started its journey deep inside the sun long before humans existed. When energy is first created in the sun's core, it doesn't shoot straight out to space. It bounces again and again, off particles inside the star, changing direction countless times, taking a slow, tangled path outward. It can take tens of thousands of years, even longer, for that energy to finally reach the sun's visible surface as light. Only then does it stream across the empty space between the sun and Earth in a surprisingly short time, about 8 minutes. So the light that warmed your face this afternoon began its journey long before your lifetime, long before your grandparents, long before your language or your cities or your history. By the time it arrived at your skin, it had been traveling, scattering, and shifting inside the sun for longer than all of recorded human civilization. You don't have to hold on to that timescale. You can just let it stretch your sense of time a little, the way you might stretch your arms before settling into bed, and then let it go. The sun is so large that more than 1 million Earths could fit inside it. If you could shrink the sun until it was the size of a hollow ball, and then start dropping Earth-sized marbles into it, you could pour in well over 1 million before you filled the volume. Its diameter is about 109 times that of Earth. And yet, when you look at it from your planet, it is just a bright circle in the sky, something you can blot out with your thumb at arm's length. This contrast between how small it looks and how huge it truly is part of the quiet strangeness of living in a solar system. So much of what surrounds you is larger and older than anything in daily life, yet appears tiny from where you stand. You don't need to imagine the exact scale. The comparison alone is enough. Your entire world is just one tiny marble in the vast bright heart of the system. The surface of the sun is not solid, but it still has weather. What we call the surface is a layer of glowing gas where light can finally escape into space. This region seethes with motion. Hot plasma rises, cools, and sinks again in looping cells, like the slow bubbling of a pot you can never turn off. Darker spots, called sunspots, mark regions where intense magnetic fields tangle and temporarily cool the gas. Sometimes those fields snap and rearrange, releasing bursts of energy as flares and sending streams of charged particles outward on the solar wind. From the safety of your distant orbit, this activity is not something to fear, just another pattern in the star's behavior. The sun breathes in its own way, expanding, contracting, flickering and calming over cycles that last years and decades. While you rest tonight, those cycles continue, as they have for ages. Our imaginary vessel hovers at a safe distance from the sun, where the glare is bright but not overwhelming. Picture yourself in a perfectly smooth, perfectly quiet capsule with wide windows, floating far above the star. You hear no engines, feel no vibrations, no wind. There is only the gentle sense of drifting, the sun filling part of your view, space stretching out around it in all directions. You don't have to see it clearly in your mind. Even a vague impression of a bright sphere in the dark is enough if your thoughts wander to something else. A memory from the day, a list, a feeling, that's fine. The vessel waits wherever your attention returns to it. Closer to the sun than any other planet, Mercury races through its orbit. Mercury is the innermost planet in the solar system. A small rocky world smaller than many moons. It circles the sun in just 88 Earth days, meaning its year is less than 3 of your months. Because it is so close to the sun, it moves quickly along its orbit, racing around the star like a tiny stone in a tight, fast loop. Despite that speed, Mercury's rotation is slow and strangely synchronized with its orbit. A full day from sunrise to sunrise on Mercury lasts much longer than a Mercury year. If you could stand on its surface and watch the sun, you would see it rise, move across the sky in odd patterns, and set after a very long, drawn-out day unlike anything on Earth. You don't need to remember the exact ratios or timing. You can simply store away the feeling that Mercury lives in an extreme rhythm. Fast around the sun, slow on its own axis, caught between heat and cold. Mercury's surface is a record of ancient violence, frozen in place. With almost no atmosphere to protect it, Mercury has been struck again and again by asteroids and comets over billions of years. Each impact dug a crater, throwing rock outward, leaving bright rays and scarred basins. From space, its face looks similar to Earth's moon, gray, heavily cratered, old. Unlike Earth, there are no oceans to erode those marks, no weather to wash them away, no plate tectonics to recycle the crust. One of the largest impact features is a huge basin more than 1,000 kilometers wide, surrounded by rings of mountains thrown up by the collision. Elsewhere, smooth plains suggest ancient lava once flowed, flooding low areas in the distant past before solidifying. If you let your imagination drift over that landscape, you might picture a quiet, airless plain under a black sky, the sun huge and dazzling above the horizon. You never have to go there. You are just visiting in thought, from a safe and calm distance. Temperatures on Mercury swing from brutal heat to intense cold on the sunlit side. The surface can become hotter than the interior of a kitchen oven. Without much atmosphere to trap heat, that warmth doesn't stick around on the night side. When a region rotates away from the sun, the ground rapidly cools. Temperatures can drop to hundreds of degrees below freezing. Yet in some deep craters near the poles, where sunlight never reaches, there may be pockets of water ice preserved in permanent shadow, frozen reminders that even in a hostile environment, strange niches can exist. You don't need to hold on to the numbers attached to those temperatures. You can simply let the idea pass through. A tiny, airless globe racing around the sun, boiling on one side, freezing on the other, quietly turning in a cycle that has repeated for billions of years. Our vessel will not land on Mercury. It will drift past it, unhurried. Imagine now that your capsule slowly shifts its path, gliding from its vantage point near the sun toward Mercury's orbit. You see the small planet grow in your window from a point of light to a disk to a rugged, cratered world. Then, as you slide by at a respectful distance, you watch it shrink again, fading back into the starlit darkness. You don't have to visualize every step. You might only sense that we have acknowledged Mercury, learned a handful of its secrets, and are ready to move on. If any of those details already feel like they're slipping away, that is perfectly okay. This is not an exam. It is a quiet tour. Farther from the sun than Mercury, but still closer than Earth, lies Venus. Similar in size to your planet, but wrapped in a very different fate. From a distance, Venus looks gentle. A pale, creamy world with a smooth, unbroken layer of cloud. It is almost the same size as Earth, only slightly smaller, and has often been called Earth's sister. But under its thick atmosphere, the conditions are extreme. The air is dense, made largely of carbon dioxide, with clouds of droplets that would be corrosive to most familiar materials. The pressure at the surface is like being deep under an earthly ocean, and the temperature is hot enough to melt lead. In the high clouds, winds roar around the planet, circling it in just a few days, much faster than the solid planet rotates below. Yet from orbit, all of this chaos smooths into slow, swirling patterns, bands and curls in the cloud tops, turning steadily around the globe. We'll explore Venus more deeply as our journey continues. For now, part 1 of this trip has brought you from the heart of the system, the Sun, out to the fast, scarred stone of Mercury and the bright, cloud-wrapped sphere of Venus's orbit, with Earth and Mars waiting still farther ahead. As you lie here, your real body is already in motion, spinning with Earth, circling the Sun, and crossing the same regions we're imagining now. Whether you stay with the story or drift into sleep, the orbits will keep unfolding. You don't need to do anything. You are carried along automatically, a quiet passenger in a system of worlds, warmed by a star that has been shining since long before there were names for any of this at all. From our quiet orbit above Venus, the planet looks calm, almost gentle, wrapped in cream-colored cloud. But beneath those clouds is one of the harshest surfaces in the solar system on Venus. A single day is longer than a year. Venus orbits the Sun in about 225 Earth days. But it rotates so slowly on its axis that from one sunrise to the next, almost 243 Earth days pass. Not only that, it spins in the opposite direction compared to most planets, including Earth. If you could stand on its surface and somehow survive, the Sun would appear to rise in the west and set in the east, creeping slowly across the sky over a day that outlasts the Venusian year. You don't need to remember the exact numbers. You can just hold onto the feeling that time itself works differently here, years slipping by faster than days, a planet whose rhythm would make our clocks feel confused and slow. Venus is what happens when a world takes the greenhouse effect to the extreme. The thick Venusian atmosphere is mostly carbon dioxide, with clouds laced with sulfuric acid. Sunlight passes through the upper clouds and warms the surface, but the dense atmosphere traps that heat like a heavy blanket. Instead of letting warmth escape back into space, the planet holds onto it again and again until the surface temperature climbs to around 460 degrees Celsius, hotter than Mercury, even though Mercury is closer to the Sun. It's a quiet, stable furnace. Rocks hot enough to glow dull red, metal objects softened, any ordinary spacecraft crushed and overheated in minutes or hours. Several Soviet Venera landers touched down on Venus in the 1970s and 80s. Some lasted only a little more than an hour before the heat and pressure overwhelmed them. They returned ghostly images of flat, shattered rocks under a hazy orange sky, proof that the surface is as hostile as theory suggested. You don't have to picture every detail of those images. You can simply let the idea settle in that Venus is a kind of warning from next door, a planet much like Earth in size and composition, but with a history and atmosphere that led it down a very different path. Above that hostile surface, the clouds themselves race around the planet. High in the Venusian atmosphere, winds can reach hundreds of kilometers per hour, circling the planet in just a few days. This superrotation means the atmosphere is moving far faster than the solid planet beneath it. From orbit, you would see the cloud tops slip and swirl in broad, sweeping bands, constantly reshaping but never entirely clearing. Yet even in this chaos, there are altitudes where conditions are surprisingly gentle. About 50 to 60 kilometers above the surface, the pressure and temperature can be closer to what humans experience on Earth at sea level. Still not breathable, still filled with corrosive droplets, but much less extreme than the furnace below. Some scientists have even wondered whether high above Venus, in these cloud layers, there might once have been, or might still be, strange forms of microbial life riding the winds. We don't know the answer, and for now it's only a quiet speculation. As you lie here, you don't have to decide what you believe about that possibility. You can just let your mind imagine the clouds and then let them drift away again, like thoughts you don't need to chase. Now our vessel begins to leave Venus behind, turning outward once more. From our imaginary window, the bright, cloud-covered planet slowly shrinks. The pale disk becomes smaller and smaller until it is just a bright point near the Sun, one more wandering star in the sky. We are moving toward a longer orbit now, toward a world whose surface you know without thinking, the planet we call home. Earth orbits in a narrow band where liquid water can exist on the surface. Not too close to the sun, where oceans would boil away like on Venus. Not too far, where they would freeze solid for much of the year. Earth sits in what scientists often call the habitable zone. A distance where, with the right kind of atmosphere, temperatures can stay in a range that allows water to remain liquid. Water is not just a detail that shapes continents, feeds weather, and provides a medium where chemistry can become biology on Earth. It fills oceans, rivers, lakes, and clouds, cycling constantly through evaporation, condensation, and rainfall. It carries heat from the equator toward the poles, moderating the planet's climate in subtle ways. You don't have to imagine every river or wave. You can just let the word water stand in for the countless forms of movement and change that make Earth feel alive. As we approach Earth from space, the first thing that stands out is color. The deep blues of the oceans cover most of the surface, broken by swirling patches of white cloud, and the browns and greens of land. A thin, fragile-looking layer of atmosphere hugs the planet, a soft, luminous halo when seen against the blackness of space. That thin layer is everything. Earth's atmosphere is a mixture of nitrogen, oxygen, and trace gases. It scatters sunlight, making the sky blue at midday and red or gold at sunrise and sunset. It holds in enough heat at night to prevent the world from freezing solid and blocks much of the dangerous radiation arriving from space. Ozone in the upper layers absorbs ultraviolet light. The lower layers carry weather, clouds, rain, wind, forming patterns that are both familiar and endlessly changing. Without this invisible blanket, your world would be unrecognizable. And yet, from above, it looks delicate, like the thinnest veil around a marble. You don't have to remember what each gas does. It's enough to know that right now, as you breathe in and out, you are part of that system, the atmosphere that lets seas remain liquid, forests grow, and you rest here, pulling air in without needing to think about it. Earth's magnetic field is another protective shield you can't see. Deep inside the planet, a molten, metallic core churns and rotates. This motion generates a magnetic field that extends far into space, forming a kind of bubble around Earth called the magnetosphere. When charged particles from the sun arrive on the solar wind, many of them are deflected or trapped by this field, diverted away from the surface. Some of those particles spiral down near the poles, colliding with atoms in the upper atmosphere and causing them to glow. This is what creates auroras, the northern and southern lights, rippling curtains and arcs of green, red, and purple, dancing high above the ground. Even if you never see an aurora in person, you are still under the protection of the same field that makes them possible. It is another quiet layer in the stack of safeguards: atmosphere, magnetic field, distance from the sun, that keeps Earth a gentler world than many we've passed or will pass tonight. Our vessel settles into orbit around Earth for a moment, giving us a full view. Below us, continents drift slowly under the moving patchwork of clouds. We might see the dark shapes of mountain ranges casting shadows at sunrise, long coastlines tracing the edges of oceans, bright streaks of rivers glinting where the light hits them just right on the night side. Necklaces of city lights appear near coastlines, dimmer clusters farther inland, and stretches of complete darkness where forests, deserts, or oceans lie. It's easy, from here, to see how small human activity is compared to the whole brief patterns of light on one side, while on the other side, storms swirl over oceans that have been there for hundreds of millions of years. If any thought from your day tries to insist that it is everything, that it is the whole story, you can gently place it in one of those tiny regions of light and see how small it becomes against the rest of the globe. You don't have to push it away, you can just let it shrink like a city seen from orbit, real but no longer overwhelming. Earth's companion, the Moon, orbits silently nearby. The Moon is about a quarter of Earth's diameter and roughly 1/80th of its mass. Its surface is covered with impact craters and vast dark plains called Maria, formed long ago by ancient lava flows that filled large basins. Because the Moon is tidally locked, it always shows the same face to Earth. The side you see from the ground is the same side that has looked down on every human generation, every night sky watcher, throughout history. The far side is just as real, equally cratered, but remained hidden from human eyes until spacecraft flew around to photograph it. The Moon's gravity pulls on Earth's oceans, creating tides. As Earth rotates, different parts of the planet pass through the bulges of water raised by this pull, leading to the rhythmic rise and fall of sea levels along coasts. Over very long timescales, The interaction between Earth and the Moon has also slowed Earth's rotation slightly and caused the Moon to spiral gradually farther away. Right now, as you rest, the Moon is either above your horizon or below it, waxing or waning, bright or thin, but always there, following its regular path around the planet. Even if you can't see it from where you are, it's still quietly tugging on your oceans and lighting some other person's night. You don't need to keep track of its phase or its position. It's enough to know that, as a constant presence, it adds another layer to Earth's long, slow cycles. The Sun, Earth, and Moon together create a delicate geometry. Sometimes they align in ways that produce eclipses, moments when one body passes in front of another from our point of view. When the Moon crosses between Earth and the Sun, it can cast a shadow on Earth's surface, creating a solar eclipse. When Earth passes directly between the Sun and the Moon, Earth's shadow can fall on the Moon, creating a lunar eclipse that can turn the Moon a coppery red. These events are dramatic when you witness them, but from the perspective of the solar system, they are simply consequences of orbits lining up in just the right way. They remind us that even shadows, when you look at them from a larger frame, are just part of a predictable, quiet dance. From Earth's orbit, Mars is already visible, a smaller, dimmer, rust-colored light farther from the Sun. If you look past Earth now, following the path of the planets outward, you can imagine the orbit of Mars, a wider circle, taking nearly twice as long to complete as Earth's year. Mars is colder, with a thinner atmosphere and a surface marked by volcanoes, canyons, and ancient riverbeds. Our journey is taking us there. We won't rush. We'll leave Earth and the Moon behind at a gentle pace, noticing how the space between the orbits opens like a quiet, dark sea between coasts. But before we drift outward, you can take one more slow look at your home world. From here, Earth is not a map, not a collection of borders, not a list of tasks or worries. That it's a single turning sphere, wrapped in air and ocean, lit by a star, accompanied by a moon. It is the place where you breathe, where you think, where you now rest. You don't have to carry the entire planet in your mind. It will keep turning without your help, cycling through days and nights, storms and calms, seasons and years. As our vessel begins to tilt outward, setting its course for Mars, you can let the image of Earth grow smaller in your thoughts, just as it shrinks in our imaginary window. You remain tied to it by gravity, by memory, by every atom in your body. But for the purposes of this journey, you are free to watch it recede, a blue and white lantern in the dark. Soon, we will move into the quieter space between Earth's orbit and Mars's, where the Sun is a little smaller, the light a little weaker, and the red planet gradually grows from a star-like point into a world with mountains, ice caps, and canyons deep enough to swallow entire continents. Whether you follow every word of that next step, or drift into sleep somewhere along the way, the planets will continue in their paths. You don't need to keep up. You're already on the journey, simply by being here, resting under the same star that lights every world we visited and every world still to come. From out here, Earth looks like a small blue light wrapped in a thin, glowing shell of AI. As we drift outward from Venus's orbit, our path gently intersects the orbit of your home world. At first, it's just another star, a slightly brighter point against the darkness. But as we draw closer, Earth swells into a marble of deep blues, soft whites, and hints of brown and green. Oceans cover most of its surface, pooling into wide basins, while clouds swirl above like slow brushstrokes of white paint. Around it, a faint halo shines. That is the atmosphere, a layer of gas so thin that, compared to the size of the planet, it's like a coat of varnish on a globe. This is the only world we know, so far, where oceans of liquid water spread across the surface and air fills every valley. From a distance, it's easy to see how fragile that thin shell of life-supporting air really is, and how precious it must be. As we coast beside it in the dark, you can just imagine this small blue sphere turning slowly, carrying everything you've ever known on its surface, quietly circling the sun somewhere on that blue world. You are lying still beneath its sky. If we zoom in our minds, down through the clouds and the atmosphere, we'd find continents, cities, forests, deserts, rivers, and finally the room where you are resting. From space, none of that is visible. The details of your life are much too small to see. All we see is light and shadow, land and ocean, day and night moving gently from one side of the globe to the other. Yet right now, while we drift past in this imaginary ship, your body is safely held by gravity, pulled toward the center of that planet just as surely as the moon is. Your chest rises and falls with each slow breath. Your heart keeps its own steady rhythm, utterly unaware of orbital paths and planetary scales. You don't have to feel big or important out here. You're allowed to feel small and safe, like someone dozing under a blanket while the train takes care of the journey. Earth is a world whose seasons are written by a subtle tilt. If you could watch an entire year flicker past in a time-lapse from our vantage point, you'd see the planet's axis leaning slightly, just over 23 degrees, as it orbits the sun. One hemisphere tips toward the light for part of the year, then away from it for the other part. Ice caps grow and shrink. Snow brightens and then recedes. Bands of green move north and south as plants grow and rest. This simple tilt is why your days feel different throughout the year. Longer summer evenings when the sun lingers, shorter winter days when darkness arrives early and mornings come slowly. None of it is random. It's just geometry, a quiet consequence of a spinning, tilted sphere looping around its star. You don't need to hold onto the angle or the numbers. You can just remember that the changing light outside your window, the shorter days and longer ones, are part of this slow, predictable dance. Earth carries a thin shield of air and magnetism that makes it feel like home. The air around you is mostly nitrogen and oxygen, with small traces of other gases. It warms and cools, turns into clouds and rain, carries scents and sounds. This blanket of air holds heat close to the surface, keeping nights from becoming unbearably cold and days from becoming too extreme. Without it, Earth would be harsh and bare, more like the moon or Mercury, with temperatures swinging wildly every time the sun rose or set. Deeper inside the planet, molten metal slowly churns. That motion generates a magnetic field that stretches far into space. Charged particles from the sun that might otherwise slam into the surface are often deflected or funneled toward the poles instead, where they paint the sky with shimmering auroras. Most of the time, you don't feel this shield at all. You simply live within it, breathing and moving through its protection. You can imagine it now, if you like, an invisible cocoon surrounding your world, quietly deflecting storms of particles while you lie here and do nothing more complicated than breathe. Earth travels with a single, steady companion that always shows us the same face. The moon. As we continue drifting alongside Earth, a smaller gray sphere comes into view nearby. It orbits at a distance of about 250,000 miles, far in human terms but close in cosmic ones. The moon turns on its axis in just the same amount of time it takes to circle Earth, so the same hemisphere always faces your world. When you look up at the moon from your backyard or through a window, you're seeing the same pattern of dark and light patches people have watched for thousands of years. Up close, the moon is a place of stark contrasts. Bright highlands, dark lava plains, craters of all sizes, and a sky that is always black, even at noon. There is no thick air to scatter light, no wind to erase footprints or soften sharp edges. The quiet is absolute. The tracks left by astronauts decades ago are still there, preserved in dust that has hardly moved since. From our ship, you can picture Earth and the moon together as a double system, both falling around the sun and around each other, locked in a slow, graceful dance that has lasted for billions of years. The moon's gentle pull has been shaping Earth for eons. Because of the moon's gravity, Earth's oceans rise and fall. High tides roll in and then retreat along coasts all over the world, twice each day in most places. Over very long timescales, this constant tugging acts like a brake, ever so slightly slowing Earth's rotation while nudging the moon gradually farther away. The change is tiny, barely an inch or so each year, but over millions of years it adds up. This quiet interaction helps keep Earth's axial tilt fairly stable, preventing wild swings that could make the climate far more chaotic. The moon doesn't just decorate our night sky. It helps keep conditions on Earth gentle enough for life as you know it. As you lie here, you can think of the tides quietly lifting and lowering somewhere in the dark, on distant beaches you've never seen, moved by a companion you can't feel but can always glimpse in the sky. For a brief moment in cosmic time, humans stepped off Earth and left footprints on the moon. From our orbital perch, we can imagine those tiny landing sites on the near side. Small spacecraft bases, instruments, and traces in the dust. On the scale of the moon, they are almost invisible, smaller than the smallest scratches on a giant statue. But for the species that made them, they represent a whole new category of experience, leaving their own world and walking on another. The moon has been up there for as long as Earth has been Earth, silently circling, indifferent to creatures crawling on the surface below. Only recently did a few of those creatures ride fire into space, cross the gap, and stand under that black sky in person. Even if you never go there yourself, it can be calming to remember that your species has already reached beyond home once, carefully and patiently, and then returned safely, the way you will eventually return from this imagined journey to your own quiet bed. To leave Earth for Mars, we don't aim straight at the red planet. We fall into a new, wider curve around the sun.in space. Travel is mostly about orbits. Earth circles the sun in one nearly circular path. Mars follows another a bit farther out. To go from one to the other, a spacecraft doesn't point right at Mars like an airplane might point toward a city. Instead, it gently changes its speed so that its own orbit stretches outward, touching Earth's path at one end and Mars's at the other. This kind of transfer is often the most economical way to travel between orbits. It takes time, many months, but it's efficient, using gravity and motion rather than brute force. The spacecraft is always falling, in a way, always in free fall around the sun, just on a new, elongated path. As we depart the neighborhood of Earth and the moon, you can imagine our ship drifting onto one of these graceful curves, turning gradually away from the blue world behind us and toward the dimmer, redder point of Mars ahead. Between Earth and Mars there is mostly nothing at all, just distance, light, and time. The gap between the two orbits is huge on human scales. Tens of millions of miles, sometimes more than 100 million, depending on where each planet is in its path. Yet almost all of that space is empty. There are no crowds of rocks to dodge, no thick clouds of dust, just the faint dusting of particles here and there, the thin breath of the solar wind, and the quiet, unwavering light of the sun. Spacecraft that make this journey spend months coasting. Most of the time, their engines are silent. They simply drift along their trajectory, moving fast but without effort, like a ball thrown in a place without air resistance or friction. Inside, instruments tick over, cameras sleep and wake, computers count out seconds. Outside, the view doesn't change much from one day to the next, just the growing brightness of Mars ahead and the shrinking disk of Earth behind. You don't have to track the miles or watch a mental progress bar. You can let all that empty distance feel like a deep breath of the universe, a long pause between one world and the next. In this wide space between planets, the sun has grown smaller, but its light still defines our days. From our ship, the sun is a little whiter, a little less overwhelming than it was near Mercury, but it still dominates the sky. Its light glints off metal surfaces and dust grains, casting long, clean shadows inside the cabin of our imaginary vessel. Nights and days here are not marked by sunsets and sunrises, but by the simple choice of whether the ship turns its window toward or away from the star. If you like, you can imagine the cabin lights dimming as we let the ship slowly roll so that the sun passes out of view. The stars come up instead, scattered in every direction, no longer twinkling but steady and crisp. Earth is just another point now, somewhere behind us, and Mars is another point ahead. There is no up or down, only the direction we choose to face. As your own eyes grow heavier, you can think of this slow roll in the dark, a gentle rotation that doesn't disturb you, just as Earth's real spin never disturbs your sleep. Your thoughts are allowed to drift here, just like the ship. If your mind wanders away from these words, toward your day, your memories, or things you need to do, that's okay. You don't have to cling to every detail of orbits and distances. They will still be true even if you stop paying attention. You can imagine your worries as tiny satellites released into space, each one following its own path, slowly moving away until they're too small to see. All that remains is the quiet hum of the ship, the distant sun, the faint glow of Mars in front of us, and the steady rhythm of your breathing where you are. The universe is not in a hurry out here. You don't have to be either. Ahead, Mars is still just a red star, but it grows a little larger with every passing day. In our minds, we can speed up the clock, letting weeks glide by in seconds. The red point becomes a tiny disk, then a small world with patches of darker and lighter tones. Little white caps appear at the poles, like a dusting of frost on a rusty ball. The sun is behind us now, off to one side, painting Mars with a softer, cooler light than the warm glow that reaches Earth. Our path curves inward toward this world, matching its motion so that, instead of racing past, we arrive gently alongside. There is no dramatic swoop, no jolt, just a quiet approach, like drifting toward an island that has been waiting in the distance all along. You don't need to picture every step of that approach. You can simply know that we are getting closer, that each moment carries us farther from Earth's orbit and deeper into the realm of the red planet. Ahead of us, Mars finally stops being a star and becomes a world. The tiny red point we've been watching for so long begins to swell in our window. First it's a pale disk, then a marble, then a whole planet with dark smudges, bright patches, and white caps at the poles. The color is not a bright fire engine red, but a soft, rusty tone, like old iron or desert sand at sunset. In the thin sunlight out here, Mars looks calm and ancient, a small, cold cousin of Earth that has been waiting quietly in its orbit for billions of years. As you picture it growing closer, you don't have to tense up or concentrate. You can let the image of that rust-colored sphere drift in and out of focus, the way a dream comes and goes as you fall asleep. From orbit, Mars looks like an entire continent turned into a desert. We slip gently into a wide, circular path around the planet, matching its motion until it hangs steady below us. The view is a patchwork of dusty plains, darker volcanic rock, and bright polar caps. One half of the globe is higher and more heavily cratered, an older, battered highland. The other half is lower and smoother, with fewer craters, as if it was resurfaced later by lava or buried under layers of sediment. This two-faced character is something Mars wears on a planetary scale. Ancient in one hemisphere, somewhat younger in the other. There are no oceans here to break up the land, no blue swaths of water, only a world that looks like the driest regions of Earth multiplied many times and wrapped around a sphere. Yet even this dry planet has its own subtle textures and stories etched into the ground. On Mars, there is a canyon so long it could stretch across an entire continent on Earth. Near the equator, our path carries us over a massive scar carved into the crust, Valles Marineris. It isn't a single narrow crack, but a whole system of canyons and chasms, thousands of miles long. Some sections drop nearly 4 miles from rim to floor, deeper than the Grand Canyon, and span hundreds of miles from wall to wall. Cliffs fall away into dusty haze, and the floors are littered with landslides, layered rock, and ridges that hint at a long, complicated history of stretching, collapsing, and erosion. Scientists think this colossal feature may have started as a great fracture in the crust, related to the way the planet's surface was pulled and strained by nearby volcanic uplift. Over time, pieces of rock broke and slumped, and whatever water or ice once flowed here helped widen and reshape the chasms. You can imagine standing on the edge in a protective suit, looking across a canyon so wide the far side fades into the thin atmosphere, knowing that the silence in that depth has lasted for millions of years. Even as you lie still in bed, that canyon remains, patient and unmoving, a quiet reminder of how slowly worlds can change. Mars also holds a volcano taller than almost anything in the solar system. On the planet's western side rises Olympus Mons, a shield volcano so wide it would cover an entire region the size of a small country. Its base stretches hundreds of miles, and its summit towers more than twice as high as Mount Everest. The slopes are gentle. If you walked up them, it would feel like a long, gradual climb rather than a steep hike. But the distance is enormous, more like walking across a state than up a mountain. Mars's lower gravity and solid, unmoving crust allowed Olympus Mons to grow so large. On Earth, the crust slides over hot spots, creating chains of volcanoes. On Mars, the crust stayed nearly still, so lava from the same source piled up in the same place over and over again, building this giant over many millions of years. You don't need to picture every mile of its flanks. You can just hold the calm idea of a vast, frozen volcano, standing silently under a pale sky, while your own mountains and hills back on Earth are hidden in night. A day on Mars is only a little longer than a day on Earth. As we orbit, we can watch the planet turn beneath us. One full rotation takes about 24.5 hours, just a bit more than your familiar 24-hour day. If you were living on Mars, you would still see a sunrise and sunset every sol, as scientists call a Martian day, and you'd still feel a regular rhythm of light and dark that's not so different from home. Mars is also tilted on its axis by about 25 degrees, close to Earth's tilt. That means Mars has seasons too, long, drawn-out springs and summers, autumns and winters that each last for months, because the Martian year is almost twice as long as Earth's. Polar caps grow and shrink with these seasons, and the thin atmosphere gently thickens and thins as carbon dioxide freezes out or evaporates. You don't have to memorize the numbers. It's enough to know that this rusty world has a heartbeat of its own, days and seasons ticking by in a slower, quieter version of the pattern you already know on Earth. The air on Mars is thin, cold, and tinged with dust. If we drop lower, skimming just above the upper edge of the atmosphere, we can sense how fragile it is. The air is mostly carbon dioxide with a little nitrogen and argon, and only traces of water vapor. Surface pressure is less than 1/100th of Earth's at sea level, far too thin to breathe, and too weak to hold much warmth. Temperatures swing from cold to very cold, often well below freezing, especially at night and near the poles. Yet even this thin air can lift dust off the ground. Fine particles about the size of talcum powder are stirred by local winds into small dust devils and storms. Sometimes these storms grow and merge, spreading across regions, and every so often they envelop much of the planet, softening the shadows and turning the sky into a hazy, uniform glow. From our vantage point, these storms unfold slowly and gently, more like a gray veil being pulled over the planet than a sudden, violent event. You can imagine them as a soft, reddish fog moving over empty plains, while you stay wrapped in your own familiar atmosphere far away. At each pole of Mars, ice records the planet's climate like pages in a frozen book. Look down toward the North or South Pole and you'll see bright, white caps standing out against the red ground. These caps are made of layers of water ice and frozen carbon dioxide in winter. The caps grow as more carbon dioxide from the atmosphere freezes onto the surface in summer. Some of that dry ice sublimates, turning directly from solid to gas, and returns to the air, leaving behind more permanent stacks of water ice. Over long timescales, these layered deposits keep a record of changing seasons and climate, much like ice cores on Earth hold clues to ancient weather. From orbit, they appear as spiral patterns and terraced cliffs, where winds and sunlight have carved into the layered ice. You don't need to see every layer. Just knowing those frozen records exist can be soothing, a reminder that even on a cold, dry world, nature keeps track of time in quiet, patient ways. Today, Mars is dry and cold, but its rocks remember rivers, lakes, and maybe even an ocean. As our orbit carries us over certain regions, we can see networks of dried-up channels etched into the ground. They branch and merge in patterns that look very much like river systems on Earth that in some ancient craters. The edges show what appear to be old shorelines, where water once filled the basin, and fan-shaped deposits hint at deltas where rivers once flowed in. Rovers and orbiters have found minerals that typically form in the presence of liquid water. Certain clays, sulfates, and salts. Layered sedimentary rocks suggest that standing bodies of water existed long enough to lay down strata, one atop another, like pages added to a book over many years. Billions of years ago, Mars likely had a thicker atmosphere and a warmer climate, allowing water to run on its surface and pool in lakes, perhaps even in a shallow northern ocean. Now, most of that water is locked away as ice in the ground and at the poles, or hidden deep below the surface. As you drift towards sleep, you can picture this world as a place that once had streams and shorelines, now resting under dust and frost, its memories written in stone and ice. Two tiny moons follow Mars, more like captured rocks than miniature planets. If we tilt our orbit just right, we can see them. Small, irregular shapes against the black, Phobos and Deimos. Phobos, the larger, is still only a few tens of miles across, with a surface covered in craters and grooves. It orbits so close to Mars that it circles the planet in just a little more than 7 hours, rising in the west and setting in the east several times during a single Martian day. Deimos is smaller and farther out, moving more slowly across the sky. Their gravity is very weak. A gentle jump from their surfaces could be enough to send you drifting away into space. Over very long periods, Phobos is slowly spiraling inward and is expected to eventually break apart or crash into Mars, while Deimos gradually drifts outward. Even the moons, in their own soft way, are part of Mars's long, slow story of change. You can imagine watching them from the surface. Tiny, misshapen moons gliding silently across a butterscotch sky, while the thin wind brushes dust along the ground below. While you rest on Earth, robots are quietly exploring Mars for you. Scattered across the planet are small mechanical travelers, landers and rovers that have made the long journey from your world to this one. Some, like the early landers, simply touched down, sampled the soil, and looked around for a while. Others, like the rover's spirit and opportunity, drove for years, far longer than anyone expected, climbing hills and crossing plains, reading the chemistry of rocks that formed in ancient water. Curiosity trundles slowly through a wide crater, studying layers of sediment that record changing conditions over immense spans of time. Perseverance explores an old lake bed, collecting samples that may someday be brought back to Earth, while a tiny helicopter has already taken short flights in the thin air, the first powered flights on another world. High above, orbiters circle Mars, relaying signals and mapping every hill, crater, and dune. They watch dust storms grow and fade, track the changing polar caps, and scan for ice beneath the surface. Even when you are asleep, these machines stay awake under the pale Martian sky, turning their cameras and instruments toward the ground, quietly expanding what we know. It's as if your species has stretched out a careful hand, letting fingertips graze the surface of this world, while the rest of you remains safe and warm at home. You don't have to hold all of Mars in your mind at once. If details start to blur, if canyon names and dates of missions start to fade, that's completely fine. You can let Mars become a single gentle image. A small red planet with white caps at its poles, a giant volcano, a deep canyon, and a thin sky under a distant Sunday. You can remember that it has days and seasons, traces of old rivers, 2 tiny moons, and a handful of robots slowly wandering across its face. Everything else can fade into the background like stars becoming faint behind morning light. The main feeling to keep is that this world is real, steady, and calmly circling the sun alongside your own. If you're enjoying drifting through this quiet, informative night, you can always, whenever you feel awake enough, gently like the video or subscribe so you can find your way back to journeys like this. But there is no need to do anything right now. For now, just breathe and picture Mars turning slowly beneath us, half in sunlight and half in night. Leaving orbit around Mars is like walking a few steps back from a campfire to see the whole campsite. We lift our imaginary ship into a slightly higher path, so we can see more of the planet at once. The volcanoes, canyons, polar caps, and plains all fit into a single rust-red globe again, off to the side. The tiny moons trace their quick, tight loops, barely visible against the dark. We've come a long way from the fierce brightness of the sun and the airless gray of Mercury, past the cloud-wrapped glow of Venus and the blue-white comfort of Earth, to this quiet red desert. All of these worlds now live together in your memory, even if the details are already starting to soften and blur. In the next part of our journey, we'll stay with Mars a little longer, not to add more facts, but to reflect on what this whole trip from the sun to this small, distant desert means for you, resting back on your home world. From our quiet orbit around Mars, we slowly begin the journey home, turning the ship so the red planet shrinks in the window like a fading ember in the dark, still glowing softly at the edge of your thoughts. Below us, Mars keeps spinning, its canyon system, its giant volcano, and its pale polar caps all slipping from view, but still turning calmly under a thinner, colder sun that continues to shine without effort. As the distance grows, we can replay our whole path in our minds, a gentle backward tour from Mars through the inner system, past your home world and its moon, all the way to the bright heart that started it. We remember the sun first, not as a flat picture in the sky, but as a real star, fusing atoms into light, releasing more energy each second than humanity has ever used, and yet feeling so warm and ordinary to you. Then there was Mercury, the compact gray world closest to the fire, its iron heart and cratered skin swinging through long days of scorching light and long nights of deep cold, silently keeping its strange, slow time. After that came Venus, Earth's near twin in size but not in spirit, turning backward under a blanket of heavy clouds, hot, slow, and hidden beneath its bright, reflecting veil, a warning that worlds can change deeply. Past those inner worlds we reached Earth and its moon, a blue globe wrapped in air and water, carrying forests, cities, oceans, and you, plus a gray companion locked in its steady dance, raising tides on distant shores. From the orbit of Mars, Earth is just a star, but we know it holds familiar air, familiar gravity, and a sky where you can step outside and feel the wind instead of the vacuum, the rain instead of thin, drifting dust. Between these planets lies mostly emptiness, but it is a peaceful emptiness, a great, quiet spacing that lets each world glide along its path without hurrying or colliding, like beads spread out along a dark string. As we drift inward in imagination, you do not really move at all. Your body stays anchored to your bed, held by Earth's gravity, supported by fabric and mattress and floor, cradled as gently as any ship in harbor. If your thoughts have blurred during this journey, that is perfectly fine. You do not need to recall every canyon name, every number, or every orbit for this story to work or for your mind to feel a little more spacious. You can let the science settle like dust in a sunbeam, keeping only a soft sense of scale, the feeling that you live in a spacious, orderly system that does not depend on you, yet quietly includes you all the same. Right now, what matters most is the simple rhythm of your breath, the way air enters, pauses, and leaves, like a small tide rising and falling on the shore of your resting body, endlessly gentle and endlessly patient. Notice the gentle weight of your blanket or sheets, the way your muscles feel heavier than they did this morning, like a lander that has finally touched down after a long flight and is allowed to power down its engines. Outside, your planet is still moving at great speed around the sun, but inside your room, time has slowed to the pace of a heartbeat, the quiet tick of a clock, the hush of night pressing softly against the windows. You are small compared to planets and stars, yet you are made of the same ingredients, atoms once forged in earlier suns, now organized for a while into a person who can listen, wonder, and then gently fall asleep. If you have enjoyed drifting on this calm trip from the sun to Mars and back, you can, whenever you feel awake enough, gently like the video or subscribe for future journeys. Tiny choices that help the channel return. There is no rush to do anything at all. This universe will not notice if you tap a button now or next week, and the planets will keep right on circling whether you remember us or not, free to come and go as you wish. When you need another night of quiet company, you can return to this voyage or choose another, letting new stories carry you outward while your body stays safe at home, under the same sky we visited from far above. For now, you can let the last images fade. The sun as a distant lantern, Mercury and Venus as tiny sparks, Earth as a blue marble, Mars as a dim red star sinking into sleep, all of them turning slowly without you. All that remains is darkness, your breathing, and the steady turning of your world, cradling you as you drift away into rest, part of a solar system that keeps moving in peace, whether your eyes are open or closed.